So we're going to go ahead and look at the area underneath a curve. What these all stand for is the right-hand rectangular approximation method, the left-hand rectangular approximation method, and finally the midpoint rectangular approximation method. So I want to find the area underneath this curve that goes from A to B. And this A to B is my closed interval, and the function must be continuous inside here. Now, I'm going to go ahead and shade the area we're looking for. So that's the area we want to find. So the way we're going to go ahead and do this is break this down into different rectangles. So I'm going to go ahead and put my rectangle here, and we're going to go ahead and call this point x1, with this point on the graph being x1 and f of x1. And another rectangle over here, we're going to call that x2, x3, x4, and this last one is going to be x5, but in general terms it's going to be x to the n, because the idea is we want to break this down into an infinite number of rectangles that get a infinitesimally small base. Now, how do you find the distance from here to here? Well, instead of calling this A, we're going to go ahead and call that x0. So that's the change, right? So this is delta x. We're going to call that delta x1. And that delta x in general is going to be delta xi, and that's always going to be x to the n minus x to the n minus 1. Now, what does that tell us? That tells us that the base of each of these rectangles, the base of each of those rectangles, we are going to go ahead and call delta xi. The way we get that from each of these are going to be subtracting those values. Now, what about the height? Now, the height we can do several different ways. And I'm going to pull this back down and make this a little bit bigger so we can go ahead and talk about the different ways I want to look at this. If I want to go from the right-hand side for my rectangle, what that means is I would be drawing my rectangle from here. And this would be the rectangle that I have. Now that changes the different height I'm looking for. we want to go ahead and now actually go through and do this. So what this tells me is that I want to go ahead and have 4 rectangles or partitions. So to do this, let's first go ahead and look at the right hand rectangular approximation. So in the right hand, we are going to draw our intervals we want. In this case, we're going to have all of our partitions be the same size. So to find out what that's going to be, it's going to be b minus a divided by, in this case, 4, but it's going to be n because that is going to be the number of partitions or rectangles. And then what we will do is, once I have that, I will take and multiply that times f of x1 plus f of x2 plus x3 all the way up until, if I was doing this on and on, it would be f of xn, but in this case I only have 4 rectangles, so I only need 4 of them. So for the right hand approximation method, that's going to give me 2 minus 0 divided by 4, or that tells me each of my rectangles are going to have a base that xi would equal to 0.5. Now, I need to find the height. All right, so how do I find that? Well, over here, this is 0.5. So in the right-hand method, I go directly up to where this is, and I need to find that point. So that point is f of 0.5, where if I plug that into the function, that will go ahead and that is just saying 0.5 squared plus 1. So f of 0.5 is just equal to 1.25. And I'm finding that rectangle. So that first one is going to be f of 0.5. Now for my second rectangle, that's going to give me at 1. And again, it's because my base length of the rectangles, each of them is 0.5. So now I am here. And the reason the right-hand method is nice is it's just whatever your x, in this case, this is my x2 value. So this is going to be f of 1. And I'm going to go ahead and continue that and keep drawing my other triangles. My next triangle up here is going to be right here at, let me change that color, at 1.5. So this is this rectangle here, or again, partition. Let me shade that one in too. And we'll do one more, and the last one it being at 2. So how does all of this work? That's going to be f of 1.5, and I ran out of room a little bit. I'm just going to scooch this over. And the last one would be plus f of 2. And again, all I'm doing is plugging all of those into my original function. My original function is f of x is x squared plus 1. So the base, or the width, of each of those rectangles is 0.5. I've made them the same. They don't have to be the same, but for ease with approximation, that's what we're going to be doing here. Plug all of those values in, and an f of 0.5 is 1.25. F of 1 is just 2. F of 1.5, when I plug that in, I get 3.25, and I do the same thing for the last one, and that is equal to 5. So this approximate area (5.75).